Okay, we are just going to go over lesson 1 today. So we're starting unit 7, and our first lesson is going to be something called the Pythagorean theorem, which I'm not sure if you have already learned, but we are just going to go over it. The success criteria is I can use the Pythagorean theorem to determine a side length of a right triangle and apply it to solving problems. So basically what the Pythagorean theorem is, it's a rule or a law in math that we can use to determine different sides of a right angle triangle. So just as a little bit of a warm-up, we need to remember how to square root numbers. So if we're going to square root, and you can just put this right into your calculator, square root of 12, 121 is just going to be like what two numbers multiplied together will give us 121. 11 times 11, so I know that the square root of 121 is 11 because 11 squared equals 121. Okay? So similarly, we're going to do square root of 70, and if you put it into your calculator, the square root of 17 is going to be 8.36666, right? And then what I'm going to say is it's going to be 8.4 because I just want to round to one decimal place as necessary. Okay, so if we're going to do that, how do we solve for b? So like I said here, because 11 squared equals 121. The opposite, just like the opposite of multiplying is dividing, the opposite of squaring something is square rooting something. So if I want to get rid of this square over here, I'm going to square root both sides. So then b will equal whatever the square root of 289 is, right, which is 17. Same thing. First things first, I gotta add these together before I square root, so let's just go and do that. Let's make it and simplify that. So 4 squared is going to be 16 plus 9.3 squared, which is going to be 86, and I just put it into my calculator, 86.49, right, equals b squared, right? So I'm gonna add those two together. I'm gonna get 102.49 equals b squared. And if I want to get rid of the squared on both sides, I'm going to square root both sides. And the square root of 102 and 49 is going to be 10.1, right? One decimal place equals b. And so just as a general rule of thumb, don't get rid of any of your, keep all of your numbers in as many decimal places as you can until the end where you round until 1. Okay? So if I went here, I'm going to say, all right, 10 squared is going to give me 100, right? Equals, what's 7 squared is 49 plus b squared. Now, I want to get b squared by itself, which means that I need to get rid of this 49 over here, right? And the way for me to get rid of that 49 is just subtract 49 on this side, which also means I'm going to subtract 49 on this side. So it's going to be 100 minus 49. 100 minus 49 is going to give me 51. 49 minus 49 will cancel out, so I'm left with b squared. I want to get the b by itself, so I need to do the opposite of squaring, which is going to be square root. And I'm going to square root both sides because whatever I do to one side, I have to do to the other. And I'm left with 7.14 equals b. Okay, so that's just a little bit of review of how to do squares from grade 8 and a little bit from the beginning of the semester. Okay, so we're going to do a little bit of investigation. So you're actually going to do this by yourself. Try and actually work through it without watching the video. You're going to have some time in class to do this as well, but I'm just going to show you how we're going to go through it in class. So it says, follow the instructions, and I'm just going to go through the instructions with you. It says, draw a line 3 centimeters long. At 90 degrees, draw a line 4 centimeters long. Then it says, make it a triangle. Measure the length of the third side. Then it says to draw a square on each side of the triangle, right? So we'll draw it on the 4 and the 3. Determine the area of each square. And then what do you notice? So let's go in and do that. Okay, I'm just going to make sure that this is recording. Alrighty, and so what we're going to do is, first things first, let's draw in that 3 centimeter long line. So I'm using my ruler. and just drawing it in here. So I'm going to say, all right, 3 centimeters. I'm going to draw the 3 centimeters at the bottom. So right there, that's 3 centimeters. So I'm just going to go in. Actually, let's put that somewhere. I like to put things kind of in the middle when I'm working here. So I'm going to put it here. Oops. So that's 3 centimeters. I'm just going to go in and label that. Then it says to make a 4 centimeter line perpendicular to that line. So I'm just going to go in and make that line. So 4 centimeters goes to about, that's about 4 centimeters, right? So that's 4 centimeters. And then you're just going to draw a line here. So I'm just going to draw a line from the top to the bottom. Oops. Sorry about that. Just going to go back here. It's obviously very hard to draw a line on your iPad, but that's okay. Yours line will probably be straighter than mine. So if you go in and then it says make a triangle, measure the length of the third side. So let's go in and measure this length of this side. Over here. Right, so I have, oops, the bottom one is 4 centimeters. So I just got to go change that, sorry. You want to make sure that you have the right measurements, otherwise it won't work. So I have 3, right, and I'm going to go up to 4. And then I'm going to draw it like this. Okay, so this is 4 centimeters. This is 3 centimeters, right? And then I'm just going to go and measure my length of this. And it is about 5 centimeters when you measure with your ruler. So the side length of that line that we drew in is about 5 centimeters. Then it says, draw a square on each side of the triangle. So I'm going to draw my square in the green. So you know if it's a square, we're drawing this 4 centimeter line over here, it's going to be 4 centimeters on all sides of this triangle, right? Because it's a 4 by 4 square, because squares have the same length and width on both sides. So I'm just going to go in, draw it out. So I'm going to make this line as green, or on this side I'm going to make it as green, and then I'm going to make my square for the 3 centimeter line, right? I'm just measuring 3 centimeters down, 3 centimeters down, 3 centimeters across, right? And then that's it. So I'm going to do that. And then I'm going to say, okay, so we have 4 by 4, and then it says determine the area of each square. So this one is 16 centimeters squared, right? Because 4 times 4, that's the area, right? Area of a square is length times width. So then 3 times 3, area is going to be 9 centimeters squared, right? And I think it wanted you to draw one over here beside the line over here as well. It's a little bit harder to draw a square, but I'm just going to draw a square like using that triangle. So maybe let's draw it like this. I know it's 5 centimeters, so let's draw it 5 centimeters up and 5 centimeters across. So let's take it one, oops. And I'm going to draw it in this color right here. So 5 centimeters across, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So right here. And the area of that triangle is going to be 5 by 5 is going to equal 25 centimeters squared. And always remember to put in the squared. Shouldn't be cubed, should be squared. Squared, Sorry, just going to draw my line back in. All right, and that's what we have right now. So it says, what do you notice, right? So we have 9 centimeters squared, 6 centimeters squared, and 25 centimeters squared, right? What do you notice about these squares? And it still might be, okay, I'm not really sure what I'm trying to find here, but let's figure out a little bit of a formula, right? So I just want you to realize that we have 16 centimeters squared, 9 centimeters squared, and 25 centimeters squared. This lays the basis for something called the Pythagorean theorem, right? So the Pythagorean theorem basically states that if you have 3 sides of a right triangle, right, and you have side A and side B, which are perpendicular to each other. So if you see this, they're perpendicular because they make a 90-degree angle with each other, right? So if 2 sides A and B make a perpendicular angle with each other, the longest side that is opposite to the right angle, so the longest side, so the one that's here, the one that's not like a straight line, it's the diagonal line, is going to be something called the hypotenuse. And I honestly always struggle to spell this. Hypotenuse. I always forget the E at the end. So that's a hypotenuse, or side C. Side A and side B are what we call the legs of the triangle. So I'm just going to put that in, the legs of the triangle. So I'm going to put them in purple, right here, and right here. What we know is that the sum of the 2 areas of the smaller square are equal to the sum of the area of the larger square. So if you go back here, if you took 16 plus 9, it would give us 25. So the sum of the 2 smaller areas will give us the amount of the larger area, right? And that is what we call the Pythagorean theorem. In other words, if we took side A, and made a square out of it, right, we would have an area of 9 centimeters squared. Then if we took side B, which we said was 4 centimeters squared because it was 4 times 4, led us to 16 centimeters squared, right? We know that 16 plus 9 is going to give us C squared, which is 5 times 5, which is going to give us 25, right? We can use this relationship to determine different lengths in a right angle triangle. In this unit, for this unit's purposes only round your final answer. So remember when I was saying before, only round your final answer? This is what I mean, because you're going to work with a lot of different decimals, right? If you start rounding earlier on, you won't get the same numbers. So try to keep as many decimal places as you're working through. You can do that by using the A and S button on your calculator. And I'll show you tomorrow if I can figure out how to show you on the screen how to do that, okay? All right, so, and then round your final answer to 1 decimal place only unless it's otherwise stated. So our typical will be round to 1 decimal place only, but sometimes I might ask you to round to more than 1. Okay? So, the best way to know how to use this is to just put it into practice. So we know that this is side C over here, which means that the legs of our triangle must be A and B here. So let's just use the formula. So we have A squared plus B squared. We're trying to find out what is side C, right? So let's just go in and do this. We're going to substitute our values in. So our A value is 4.2 squared plus 9 squared equals C squared. So let's go in and find out what those numbers are. 4.2 squared is going to give us 17.64. And then 9 squared we know is just 81. Equals c squared. Then when we add those two together, we know that 98.64 is c squared. And now we want to get that c by itself. So we're going to square root both sides to get the c by itself. This cancels out with that. And we're left with 9.9. And this is what I mean. Leave the 64 as a whole decimal. Don't round it to 6. 9.9 equals c. So I know side c, I'm just going to go back here and say, okay, side c is equal to 9.9 centimeters. Cool? That's easy, right? Now, what if we make it a little bit more complicated? We know that this is side A. We know that this and this are the legs. So this must be side B. We know the diagonal is always going to be side C. So let's just start plugging in what we know. We don't know what A is, so we're going to leave it as A squared. Plus, what's my B? 6. So we're going to plug in 6, and we're always going to put it in brackets. Squared. Equals, my C squared is 11.5 squared. Right? Let's start solving. A squared plus 6 squared is just 36. Equals 11.5. If we square that, it's going to be 132.25, right? Now, I want to get the a by itself. I want to get the a squared by itself. So knowing what I know, I'm just going to subtract 36 from both sides, right? Because I know these will cancel out. So I'm left with a squared equals 132.25 minus 36. Cool? Alrighty. Now, let's just do the math. 132 minus 36 is going to give me 96. I'm left with the 2.5, or the 2.5, right? And I'm still left with a squared, so to get rid of that squared, I'm going to do square root on both sides. And a is going to give me 9.8, and I'm always going to put my units in, which is centimeters in this situation. So I know that side A must be 9.8. The best way for you to check if you did this right is this side's always going to be the largest. So if you get a larger number than side C for A or B, you know you did something wrong. Okay? So it says to determine the perimeter. Now, on D2L, I have posted in a separate tab, if you go under your content, it's going to say formula sheet, and it'll be the first lesson that shows up under lesson 5. It's just going to say formula sheet. Under the formula sheet, it's going to say formula sheet for 2D and 3D shapes. I would print this out and keep a copy on your table, or write it out for yourself. Okay, so on that table, it tells you what the shape is and then the area and perimeter calculations for it. So I'm just going to go here and I'm going to say, all right, I have a square, I have a triangle here. What is my perimeter for triangle? And it says that my formula for perimeter, and you can use this on a test or a quiz, is A plus B plus C. Right? So I'm just going to go in and I'm going to say, okay, I need A, I need B, and I need C. Oh, C is going to be already given to me. So I know I have C because that's my diagonal. I have B. I need A. Right? So before I even do anything, I got to go find A. Let's do that now. Okay? So how can I find A? Just from looking up here, I'm just going to plug in what I have. A squared plus B squared equals C squared. Okay, I don't know what A is, so I'm going to leave A alone. Plus, my B is going to be 9.8 squared, and my C is going to be 19 squared. And I know this is meters, but I'll put the meters in after. A squared equals 9.8 squared, so I'm just going to put that into my calculator, right? And find out that 9 squared is 96.04. And then 19 squared I know is 361. Now I want to get the A squared by itself, so I'm going to do plus 96.04. To get rid of it, I'm going to do minus 96.04. I'm just moving it to the other side. And whatever I do to one side, I have to do to the other. These two cancel each other out, so I'm left with a squared equals 264.96. Right, I want to get the a by itself, which means I need to get rid of that squared by getting a square root. I'm just going to square root it. And I'm left with 16.27759, whatever that is. So I'm going to say, all right, let's round it to one decimal place. So it's 16.3 meters. Am I done? Did it say to find what side A was, or did it say to find the perimeter? It said to find the perimeter. That's why we wanted to find side A in the first place. So let's go back and find the perimeter. Perimeter is equal to 19 meters plus 9.8 meters plus 16.3 meters. Right, let's just add all three of these together. So let's do 19 plus 9.8 plus 16.3. And that's going to give me 45.1 meters. And that is my perimeter. So I'm going to say, therefore, always write a therefore statement, the perimeter sorry, 45.1 meters. I'm just going to make a little cloud around it because that's my final answer. Okay? So as always, as we move on, it gets a little trickier. So it says to determine the side length of x. We can't do a squared plus b squared equals c squared here. And the primary reason for that is that this entire triangle, if we look at it, the entire triangle as a whole is not a right angle triangle. So we have to figure out a different way to do this. So what I do is I'm like, okay, there's two right angle triangles actually in the middle of this triangle. So let's go and find, right, what x is up until here. Because I have one part here and I have another part here. So I can find out what x is, or what c is here. So I can do a, this is my c, and I can find out what b is. I can do the same on the other side. I have this line here. They just happen to share a line, but I have all of this. So I can find out what b for green is too, right? Because this is still my a, b, and c. So let's find out what these two bottom parts are. So let's find out. I'm going to make b x orange, and I'm going to make this x green. I know that the total x total, is going to be however much x orange is, plus however x green is. So let's find the individual ones first, right? So I'm just going to split these up into two different into two different triangles, and I know my a squared plus b squared equals c squared, right? My a is 32 here, so 32 squared. My b, I don't know, but I labeled it as x orange equals, my c is 20, so I'm going to do that squared, right? So I'm going to do 32 squared, which is going to give me 1024, plus x orange, right, squared. I still don't know what it is, so I'm going to leave it. 20 squared is going to give me 400. Oops. I made the mistake. Sorry. My C is always a diagonal. So this is actually my A, this is my C. That's my bad. So I just need to go back and change the 32. Sorry. This is what happens when you try to rush through it, right? You make silly mistakes like that. So I have 400 here plus 1024. Just change the way that the numbers were. Right, now I want to get this x orange on its own, which means that I need to get rid of this 400 here. So what I'm going to do is I'm going to do minus 400 on this side, which means that I got a minus 400 on this side. 400 minus 400 just gives me 0, so I'm left with x orange equals 1024 minus 400 is 624, right? This x orange is still squared, so I just need to make sure that to get rid of that squared, I'm going to square root both sides. So I'm left with xo equals square root of 624. When I plug that into my calculator, I get 25. So that means from here to here, I'm just going to make that a little bit nicer. From here to here, it is 25 meters. I want to find out what it is from here to here, right? And I can find that by using the 25 and the 20 from the green triangle. So I'm just going to draw in my triangle separately here so that you can see where I'm getting these numbers from. 20, and then I have the 25 up here, and I'm looking for what x green is. Okay, so again, I'm going to do a squared plus b squared equals c squared. And if you want, you could actually do this another way and just move, if you label this a, b, c, I know I'm going to isolate for b, so I can just move the a over right away. So I can say b squared equals c squared minus a squared. I could say that as well. Okay, so my b squared is, I don't know what that is, so I'm going to write that in as x green squared equals, my c squared is 25 squared, right, minus a, which was 20 squared, equals 25 squared is just 25 times 25 times 25 times 25 times 25, which we already know was 624, but you can just put that into your calculator. 25, sorry. $625 minus 20 squared, which we already know is 400. So let's just do that. 625 minus 400 equals 225. Right, so it's still xg squared, x of the green triangle squared. We want to get rid of that squared on that side, so we got to do square root on both sides. 225 square root is xg is equal to 15. That means that this side is 15 meters. So if I wanted to find the entire length of x, I would just take those two x's equals 25 plus 15, and that's going to give me 25 plus 15 is going to give me 40. 40, and it's meters, so I know that it's meters. So it says determine the side length of x. Just going to go and write my therefore statement. Therefore, the length of x is 40 meters. Okay. Alrighty, last example. So it says, this is more of a word problem. So you know that your box has the dimensions of 8 centimeters by 5 centimeters laying down, right? So we want to know, does an 11 centimeter pencil fit into that box? First things first, I always like to say, if you've got a word problem and they don't give you a diagram, draw one for yourself. So let's draw one out. This is our box. Okay, this is our box. We know that it's 10 centimeters going this way and that it's 5 centimeters going the other way. Okay, so let's take this pencil. I'm going to draw this 11 centimeter pencil out. I'm not an artist, so I'm not even going to bother trying to draw it out. If I tried to fill it this way, would my pencil fit? No, my pencil would not fit. I still have 1 centimeter here. So that's not possible. Okay? So forget it. It's not going to fit that way. Let's see. Is it going to fit this way? I know that looks like a really big pencil. Oh, sorry. This way I'll only have 1 centimeter left, but I have 10 centimeters that will fit in, but 1 centimeter will be out. If I try to fit it in this way, I have 5 centimeters that will fit because it's only 5 centimeters, and I'll have 5 centimeters that will be out. Both ways don't work. So I know I can't fit it in that way. What's another way that I could fit this pencil in? Logically, I could fit it in this way. I could fit it in diagonally. I could try to fit that in. But I don't know how big this box is diagonally. So let's figure out how big this box is diagonally and if I can even fit an 11 centimeter pencil in there. Okay? In order to figure out how big this box is diagonally, what I'm going to do is I'm going to find, and I'm just going to draw this in so that it looks nicer. Right? I want to figure out, okay, how much is this length? So this is our C. This is going to be A, this is going to be B. It doesn't really matter which one you put as A and B. So I'm going to say A squared plus B squared equals C squared. Okay? A is going to be 5 centimeters squared plus 10 centimeters squared equals C squared. 5 centimeters is 25. 5 times 5 is 25. 10 times 10 is 100 equals C squared. So I'm left with 125 equals C squared. I want to get C by itself, so I'm going to draw in that way. And I know that if I do square root of 125, I'm given 11.1803399. I'm just going to round that to 11.2 is equal to C. So that means that this box from here to here has 11.2 centimeters of space, right? My pencil is only 11 centimeters, which means that therefore, yes, you can fit an 11 centimeter pencil into the box diagonally. So there's this YouTube video that you can watch with the lessons that we did from today. There's also in your PDF, if you go and you look it up, there's actually this link at the bottom that also does a really, really good job of explaining Pythagorean theorem. So I would check that out. Your homework sheets are posted in D2L under lesson 1, Pythagorean theorem. There's a sheet posted there. It says homework, right? There's a few questions on it. It's about 3 pages. The answers are on the 3rd page. And then you also have your homework problems from page 446 on the textbook, numbers 3 to 5. And you can check your answers in the back of the book. Okay? See you tomorrow.